Okay. So yes, welcome everybody. This is a beautiful day, and I hope I hope we see all of our good, beautiful faces by the end of this meeting. I'm Preeti. I I found this chapter GDG study, and we are trying to just bring all the developers and students, professionals together. We usually focus on machine learning and AI related content, but we also go with the general developer related content in web development domain, in QA domain, and whichever the community needs. Um, we also try to run different events, different types of sessions in nature, like just mental wellness. Not That's not related to tech, but we want everybody to feel good and then do whatever they want to do. Platform is free for everybody to come and initiate any kind of activity. All you got to do is just send me an email, or anybody else in the team send us an email with the proposal, and you will take that initiative with the platform, because we believe in sharing resources, and these are everybody's resources. That's what the community is about. So yes, again, thank you. Let's support each other, and let's get started with this paper reading club. Um, as I was discussing earlier, the focus is on more on collaborative study. Come together, let's study as a group. Break the papers down. If they are bigger papers, break them down into multiple sessions, and try to educate each other, learn from Google, and then try to educate each other from whatever reliable resources you learn from. And finally, we'll hopefully have a GitHub repo, good GitHub repo where anyone else in future, if they are looking at the resources, then they get a clear sneak peek into what we have already done, and hopefully it will help them as well to find a foundation on some of the topics. So yes, that's pretty much we are going to do in this paper reading club, and hopefully we'll learn too along the way, and we'll make good friends. Okay, so thank you everyone.
Thank you, Preeti. So let me quickly introduce the paper. Welcome everyone to GDG Saris ML Paper Club's session 2. Today we are going to take up Semantic-enhanced Programmable Knowledge Graph, SPG. This has been kindly submitted by Sergey. Thank you, Sergey. Before we just move ahead, let me just tell you what exactly we are into. SPG, or Semantic Enhanced Programmable Knowledge Graph, is nothing but a semantic framework. Semantic is like just understanding of knowledge. So it's a framework which is just a step above the traditional knowledge graphs we have seen around us. Um, but what's a knowledge graph? Knowledge graph is nothing but it's basically a graph where all the nodes are your entities, like a person or a car or a pillow, and basically the edges are the verbs that a person drives the car. So drives the would be your edge. So on a very layman level, that's a knowledge graph. Now when a knowledge, so all through these many years, like in last 15 20 years, we have had basic graphs being used. SPG, or Semantic Enhanced Programmable Knowledge Graph, basically adds a language understanding to it, and it trains on enterprise data. So this is what we are going to cover today, but we would take it slow because we would like to build an understanding around it, and then finally we will basically go ahead and cover the whole paper. So for this session, we would take two chapters. So the first chapters just talk about how traditional knowledge graph functions, what exactly are predicates, what exactly is LPG, that's labeled graphs, and what exactly are how do you add a LLM do you have to add a LLM component or not, and if we do, what exactly are the advantages of it. That's basically covered in the second chapter. Now, if what Vicky, you can let us know how do you want to go forward with this. If you want, we can go ahead and divide. So there are not a lot of chapters. Let me just scroll down real quick. Oh, I forgot to mention. That's a very important thing to mention. Um, this has been basically provided by Ant Group of Technologies based in China. And this is an amazing approach where they are trying to basically standardize enterprise knowledge. They have talked about a use case in chapter 2, which is basically one of the standardized one of the uses or one of the advantages of standardizing knowledge which is scattered across their documentation. So that is something which is being covered in chapter 2. So chapter 1 is from data driven to knowledge driven. We found that chapter 1 and chapter 1, chapter 1.1, section 1.2, all of them are basically kind of transferable. So uh, all in all there are 14 chapters. If you want, we can divide 2 to 3 sections each, and we can take those up. And or if you want, we can basically go like we did the last time. We can pitch in our own opinions, and let's see how we basically take it forward. So what exactly is the opinion of the crowd? Let's see in the chat. Sergey, do you have any 2 cents?
So, sorry, can you repeat?
Or do you have any opinions around? Do you want to take it up, or do you want me to take up like we did the last time?
Yeah,
Or
if you want, but I have my annotated version. If
oh,
you want, you can I can share with you. Is it okay?
it's completely welcome. If you have your annotated version, we would be happy to see it.
But how to share it? So I will give you like a public link. Give me a few seconds, okay?
For
Or
sure.
can I share with this chat, because I can find any option how to do that.
Oh yeah, I think you are the presenter, so
Yeah,
I
I'm
don't
already
have
presenter.
access to the chat. But
I can only share the screen.
mhm,
Okay, but if you want, I can share.
sure,
Okay.
you can share it to me on LinkedIn, and I will put it in the chat for everyone. Hello, hello.
Yeah. So I will share the link with you, and give me 1 minute, okay?
Sure. My camera has stopped functioning. I don't know what's wrong with it. Meanwhile, if does anyone know what exactly are predicates in sentence transformers, or in in English language, or how was the concept of using English language for database derived? What exactly are those? Does any if anyone knows, they can put their thoughts in the chat. Perfect. I have your paper, Sergey, so I will share if you want to go ahead with it. Yeah. Sergey?
Yeah. You can click this yellow exclamation like balloons. Yeah, and there's yeah. I can start.
Okay. Not. Let me download it.
Okay. Sorry for technical issues, but
No worries. Okay. There
so
you
yeah,
go.
this explains what is a SPG framework and how it differs from other like technology like Rack framework. What is the what is like for and this explains the SPG framework speed up knowledge integration across large-scale enterprise data, and it supports connection with LLMs, and it makes the data understanding more reliable for building the business systems, yeah, and that needs more accurate data understanding. So so let me check the knowledge graph description. So this chapter describes what is a knowledge graph and how we can use it in how we can utilize it and efficiently collaborate with the data. So this approach show us how to describe the data with ontologies like OL and knowledge graphs. So yeah, we can switch further for the next page.
Okay. So do you want to talk about RDF, owls, and everything?
Yeah, this RDF owls is like not modern approach. It's like description of the data that describe not only objects but object hierarchy and how it connects with each other with the nodes and yeah, this linkage of the data. But this paper also writes that it's not enough. So this object relation is not enough to describe the data and events. And further in the next chapter, not in this chapter, because this chapter is based on the like challenges and describe the SPG as a technology, the system as a whole. Yeah, but next chapter describe how they improved this ontology and infrastructure with the additional like time time part that describe it this structure better than that. So it solved this challenges and describe this data better. So we can you click please on this yellow balloon?
Yeah, sorry, Sergey, I was giving speaker rights to everyone.
Yeah, sorry. So this points so on RDF and OWL, yeah, and so it's like labeled property graphs, and so it faces challenges, yeah, that efficiently describe and managing the knowledge. So and these challenges comes from the structure of the oval, and because it's not well described the digital world. So we can add a new component that I mentioned. It's a time component, and solve such issue. So yeah, in further text we can find the solution. So you can also yeah, can you scroll just a little down?
Yeah, just to add to what you are saying, the temporal component part. So there's just a quick figure they have given, which is a neat figure which you are talking about. So there you go. When you talk about RDFs and owls, basically they are nothing but how do you define language for databases or language for machines, right? So,
Yeah, exactly.
um, for example, you have to say that Tom is going to buy a bread. So Tom becomes type person, going to buy becomes the edge, and bread again is the subject. So English is written that way, right? Subject, predicate, and I am forgetting. Uh,
Object.
but in when you do SPGs, so it basically adds a semantic component to it, which just basically means that when you say that going to buy is my edge, it understands what going to buy is. So it can well differentiate between going to buy or have bought already, because because there's a semantic understanding to your SPGs. Now there's we will talk about further, like Sergey, if you can talk about that, why basically we felt the need of going from owls and RDFs, because till now owls and RDFs have been working completely fine, and they have basically also you know uh, made RDFs in such a way that you can create XMLs out of it and can do XSLT transformation on it. Then why exactly did we felt the need that no, we have to think about the temporal component, as Sergey was saying, or why do we have to think about the deep context of the entity features? What exactly is the need, right? So we will check all these things. Uh, for the time being, let's see what Sergey has to say about generation of knowledge semantic framework. This one, right? SPG semantic specification, Sergey. This is what we are
Yeah,
talking
yeah,
about.
yeah. That's exactly that we are talking about.
There we go.
So yeah, this approach allows us to not only have the structure of the data, but show the linkage of the data, and so we have like a programmable approach to build and align graphs across multiple domains. So simply we can connect these graphs with programmable interface, just write like a coding like coding the function how that entities connect with each other. So this is like improve approach how to deal with the data and how to describe the data to the LM properly, and it also solves the challenge. One of the challenges that described next to that further in that document. It easily allows easily manage that structures with programmable interface like language that allows to describe that connections. So we can go further with to the next page.
Hey, hi. I have a question about the programmable interface. Could you elaborate
Yeah.
more on it? Like, what exactly do you mean by programmable interface here?
You can describe that some object can do actions and what the properties of the action. So simply it's described like a digital word. Who do something, the actions and events and triggers and etc. So you can describe that in a simple language, like not only like ontologies. Uh, but and events that during the time.
But how is it programmable? Like, what's the programmable part of it?
What's programmable? So in this paper is not well written because it's written only as a few examples next in the next chapters, but it's uh, like classes, yeah, and the functions, simply as that.
I see.
Okay, so just to add to what Sergey says, for example, we all know Neo4j, right? Neo4j works on knowledge graphs. So Neo4j is nothing but your interface which gives developers access to work with these frameworks. So for example, so in the same manner, this is a framework they have been talking about. They are not giving out a tool, or they are not saying that, hey, this is a library you can use with Python. No, no, it's not that. They are saying that I am telling you a way of working, a way of defining data, and then you can basically use this particular way in any way you want. Like, you can use it, you can write libraries around it, you can integrate it with existing tools which are there. So programming, a programmable interface on the whole is anything which you can define, design to interact with such a framework.
Yeah, but in this repository, they provide a comprehensive framework and programmable, I mean, code on Python. It's completely a complete solution to build KAG, like KAG. They call it KAG, knowledge augmented generation. Yeah, and this they built the solution that allows you to use it in like in production. So in the same repository as this paper, in /KAG, they call it KIG. There is another paper, but based on this framework. But first, I need to
Have they
understand
implemented this framework, Sergey? Sorry to
yeah,
interrupt.
yeah, they implemented. I can share this. I will share later. Yeah, they have implemented and they built a ready solution. So I tested
Perfect.
it
So,
well, and yeah, it works like a charm.
yeah, so if you can share the repo with the audience over here, maybe Udit will get a little more direction here.
Yeah, I will share after this event. Yeah, by the end of this event.
Thank you for the question, Udit. Um,
So yeah, we
meanwhile,
can continue. Yeah.
yeah. Meanwhile, as we have completed the preface of, I think, okay, sorry, we have just completed the recommendations as of now. If there is anyone who wants to pitch in something, they would be welcome to. Or if anyone has some unique take on the direction, they would be welcome to do that. Hey, Dino.
Hi.
Yeah. So shall we move forward? Okay, so I think here Sergey is talking about SPG framework, how basically they have built upon property graph, and how basically they have combined the. Okay, let me just, before we go ahead and do this, let me just quickly show you how RDFs and OWLs look. So RDFs and OWLs are not today's thing. They have been defined since last 25, 30 years, and all this time. All the major databases. So the database functions on this particular semantic, right? On this particular structure. For example, if you see, this is basically I'm telling that John, RDF type is a man. John. Now I want to say where John lives. So if I just speak in English, then I can say like, yeah, John lives in New York. No, but like you have to make machines understand that. So that's why you say John lives in New York. Now, lives in is a RDF type property. So it's a property of John. And the property of lives in would be New York. So this is how RDF is built. And on top of RDF, OWL was built. So OWL basically what it said that, hey, now I can add inheritance to my things, which basically means that it just simply says that if uh, how do I say it? If person A is child of person B and person C is child of person B, then person A is the grandfather of person C. So that builds a inheritance relationship, and that's what OWL did. And on top of this, now just to basically talk in a layman term, because I try to understand. I try to wrap my head around concepts. So just talking in layman terms, owl was successor of RDF. I think not the immediate successor. After 2 3 more frameworks came, and what they have done is they have taken use of owl, and they have taken use of RDF, and they have added semantic context to it. Now, that just means that John lives in New York. Now, lives has a meaning. Lives is not just a type. It understand lives basically mean that okay, they are talking about a location. It seems right, and this sort of framework they have utilized in many. For enterprise data, and we would go ahead and see that why basically this sort of data, when we see it objectively through in the world, how we see it at a very simple level, and when we try to basically go ahead and see it in the enterprise level, then there are so many complexities which get added to it. And by complexities I mean there are so many layers of data which gets added to it. So we can talk about the preface, or Sergey, or we can just go ahead and start talking about the chapters. What do you prefer?
Yeah, we can go start from the chapter. So the main construction of SPG. So the leakage of this time component. So we can discuss the transition from binary static to multidimensional dynamic approach. So it's like knowable management paradigm. So this on the page, on page 2. So the main idea that the ontologies and LPG is based on the subject, predicate, and object. So they enabling structured data storage and efficient querying, but it's not enough for describing in events to make it easy to understand for LLMs and to build efficient understanding for the RAG and business solutions. So we can continue with knowledge layering of SPG. So and it highlights that SPG's ability to organize knowledge in layers, like from dynamic to static, and to make it to provide clarity and manage complexity. So we still continue to have a complex to describe complex documents, but we can also organize this relation between that structures to make it easy to understand for LLMs. So the main idea for this approach is to partly share this this understanding of the of text of information, and to describe it with well-structured data, and organize the connection between that structured data with the text. So and knowledge layering of SPG, it shows that how SPG organize this knowledge by with the layers. So from dynamic to static, and then we can go to the programmability of SPG and the new domain knowledge graph. So we can go further.
Okay, so do you want me to go down and elaborate?
Yeah, down. This is that we discussed. This combining knowledge graphs and LLMs. This is what I was talking about. Yeah, we can go further.
Okay, so combining knowledge graph and LLM is nothing but adding the semantic context to existing owls which we were talking about. So how do we add semantic knowledge to something is by utilizing the power of LLMs. So this is section 1.4. Like 1.3 basically goes ahead and talks about the same thing, that it basically talks about what happens when you add semantic knowledge and how basically things are used around the industry. For example, if you use only LLMs, then it's mostly, writing assistant jobs in enterprise. And if you just use knowledge recommendation, then sorry, knowledge graphs, so it's mostly used in recommendation systems. But when you enhance it by utilizing knowledge graphs and LLMs, then you can do both, right? So you can do your own recommendation system, and you can basically have your decision making doing done around that, and you can utilize the writing assistant part and eventually create reports, analysis, and all those things. So this is just one example how you are, leveraging the power of LLMs. So moving forward, it's 1.4, developing of knowledge graph technology system, and how we need to keep up with, recent times, because we see that LLMs are all around us. Sergey, would you like to take over from here?
Yeah, continue. So yeah, as we discussed that, the time is important, and it allows us to build a machine readable digital world with unified semantic representation. So allows to summarize the core goal of SPG. It's like to unify machine perceive and reason about knowledge across domains. So we can connect different domains, different constructions of data, and organize it with adding time component. So we can then go further, like so that SPG allows us to define digital knowledge clearly. So it states that SPG lays out strict rules to clarify the nature of structure of knowledge entities in the digital space. So simply it allows to describe digital world more clearly and accurate, because simply only LLMs can do the mistakes, because from different perspective of object. So the attention mechanism can lead to simple mistakes, and this approach allows to avoid such mistakes. So yeah, that the main stuff of this paper is like it built on two entities, like so it allows to automatically classify and hierarchical organization. Yeah. So simply this mechanism allows us to write these structures automatically. So it understands that structures and build this like OL ontologies and organize connection between that ontologies. So simply it's automate the process that before people have to write that ontologies on their own, and now this approach allows to build it automatically. With automatic classifications, it shows how SPG automates the grouping of knowledge subjects into consistent hierarchies to handle complexity. So it allows to organize complex structures, and it's automate the process. And important stuff is it's ensured the uniqueness of digital entities using SPG, because one of the challenges that LLM faced, they can build the different entities for the same entity. Like it's written in different contexts, in different part of the text, and sometimes LLMs build this understanding not correct, like it's two different objects, but with using of such ontologies, we can describe that object as the same class and with different properties and like events.
Thank you, Sergey. So, if you have to summarize this, how would you summarize it? Or better, let's ask the audience if someone wants to summarize what you just said, so that we can gain a full knowledge around this and basically move ahead with chapter 2.
Okay,
So,
the chapter 2 described the challenges and but that it's not accurate now. And
Sir,
yeah,
I'm sorry. Just like to give 15 seconds if someone in the audience would like to summarize what you just said.
okay.
Jane or Michael, you would like to just go ahead and just like enlighten us if you what you got from Sergey's delivery. Going once, going twice. I'll just go down to going once, going twice, going thrice. Okay. So I think what you have written over here, main focus of the life cycle, full life cycle of knowledge management, knowledge construction, and knowledge reasoning. We're trying to do that, as we said, the whole game is with the edges over here, right? Because we are really good at identifying our entities already, but we are not good at basically understanding the relationship between those entities. We in olden days, oh my god, it's just like 15 years old. So in those days, lives and eats didn't have other meaning, so that's what they have done. But that in industrial context, that's so in I'm just like trying to dump it down for myself. That's what is being done. We now understand the predicates as well. But why do we have to understand the predicate? For which we would like to understand that why in the first place labeled property graph or LPG was challenging. So that's what we will take. And just before we move forward, Sergey, it's 11:30. Sorry, we have like 10 more minutes on our clock, because we started 15 minutes after the time. So let's basically take 10 to 15 minutes. Um, of, post the finishing time, if that suits with everyone. If anyone has any other commitments, please feel free to drop. uh, do let us know what are the other papers you would like to see in future. And if you have time to go through the paper on your own, please feel free to annotate it and submit it. Yes, Dino, please.
I reckon that we could go through the data papers because I found a plethora of them in Facebook or LinkedIn.
If you have, yeah, sure. If you have any, papers in mind, you can put in the link here, or you can give it to me over LinkedIn, or give it to any of the GGG Surrey members. We run a poll. For next 3 sessions, we would be covering this paper, and after that, we are up for taking any paper. Which, if you have something in mind, if you have a link around it, and if it's in, behind a paywall, then you can submit a PDF directly to us. That anything works.
Does this include ebooks?
EPUB, what exactly is that? Sorry.
An ebook, EBOOK.
Oh, ebooks. Depends. Is that a research, ebook around some sort of research? If it is a research, then if the ebook is, lengthy, like 24 to 25 chapters, then that falls out of our scope, because we are primarily trying to cover papers. That can be research paper, then that can be a white paper.
I understand.
Thank you. Meanwhile, Sergey, if you want to take up chapter 2, please go ahead. And at the same time, I'll put in the link of our GitHub repository so that people
Okay,
can.
so if we have not much time, so I will, pay attention only on few challenges and the leakage in that approach. So I described only 4 challenges. So in paper was written like 3 challenges, but it's not, not figured out, but there are 4 challenges. Like first challenge, like continuous integration of evolving that data structure. So in business cases, the data could be changed from time to time, and with adding some properties or changing some properties or adding some substructures in the data, like maybe company grows and appears new branch, or I don't know, the changed director structure of the company. Yeah, it's like simple example, but in business scenario it could be more complicated scenarios. And this LPG, SPG allows to add functionality that automatically describe this data structures and gives additional properties to that data. So the second challenge is redundant type of creation and consistency. So it highlights the new entity relation types and proliferate risking duplication and inconsistencies in knowledge graph schema. So simply as a like connection between relation between 2 data is also could change it from time to time. And naive property relation is like the third challenge is naive property relation module fails because it cannot capture semantics and dependency between knowledge graphs, and even if that knowledge graphs evolve, so during they changing. So explains that pure property relation approach is too simplistic and does not capture deeper semantic logic or dynamic dependencies. And the fourth challenge is like too much coding work. So it was figured out by me. So because to simply describe the ontologies, we need to to write a lot of classes and the relations, how to the one of the property relate to each other and to the parent object, subject, object, and predicate. So this challenge also will be solved with SPG, with automatically relation and description of the objects. So they provide 2 mechanisms. That one of the mechanisms is to build object description, and second, how that object relate to each other. So yeah, that's all for this chapter second. It's like very shortly. I described more than I can speak now, but yeah, we can concentrate or on third chapter if I have a chance later. And I don't know, we can continue and write the final, like on the second chapter in the end. There are a few challenges that describe very shortly. You can scroll down. You can scroll down if you want. Yeah, this is it. This is it. Difficult to manage and continuous integration, continuous change of knowledge graph structure. This is challenges that I've mentioned.
Okay. So I think what we have gathered today, I would like to paraphrase what just Sergey went through today, that we understand that in today's world, everything is data. And that's the case with enterprise as well. And chapter one, which we went through, it highlighted the potential of knowledge graphs, you know, to be used as a knowledge management paradigm. For example, we can basically, as Sergey was saying, right, it identifies its own semantic relationships. So we can fully automate this thing. Now, but we have to take care that our data, for these graphs to function, it should be organized. And that's how our SPGs can have better contextual understanding, and we can make our decisions better. But the need for these dynamic and multidimensional models, as basically Sergey was saying, it is clearly evident right now. We need this because the LPGs and the owls, they are not up to the mark with the current time which is there. And that's why we needed to integrate with LLMs so that we can have better semantic understanding of the relationships between different entities in the graphs. Chapter 2, basically we focused on the challenges of the LPG based knowledge graphs. And in this you would see that the whole idea is around risk mining knowledge graph, right? So what exactly Sergey was trying to talk around in risk mining knowledge graph is, let's say you have elements who are trying to invade in your system. Let's say, like, have a very simple example. Now you need to have better understanding of those entities in order to in order to identify the risky ones. So if you see in this picture as well, you would see that this is a very simple picture. It's an original graph data because you don't have a lot of information all the time. But after you basically integrate it with the business rules and integrate it with your SPG, it will find out new types of relationship. So these sort of these sort of use cases are very good for SPGs, where you need to find out relationship which is not evident or which is not visible on the first glance. So that's what is being talked in chapter 2. Now, if we have to take a look on it as a whole, we have to understand that we do need programmable semantic rich frameworks like SPG to identify and to drive innovation in enterprise knowledge management. And that's how we have to do it. How they are suggesting it to do it is through AI driven decision making and incorporating LLMs. So that is what we covered today. Next time we would be covering chapter 3, 4, 5, 6. So basically, in the next session is going to be heavy, intensive session. So chapter 3 is basically getting into the core of SPG, then how a SPG schema layer looks like, how SPG engine layer works, and how SPG controller layer will work. So if you want to gain, full potential, if you want to unlock your full potential, if I say, and gain as much as you can from these sessions, I would suggest you to skim down all these chapters. Doesn't matter if you understand it or not. That's what we will try to do as a group. We will try to understand it as a group, and then we can have collaborative discussions and in the session, that what did you understand, what was Sergey's rationale, what was Michael's rationale, and we can come to a conclusion of sorts that, hey, probably this means we can have a collective understanding of everything. I hope, and thank you so much, Sergey, for walking us through so many topics today. And your annotation was amazing. I would just ask you to have it written in, instead of in the comments. If you can take screenshots also around it, it will look beautiful for your README page. Other than that, your annotations were amazing. And thank you, everyone. Thank you, Dino. Thank you, Jane. And I don't want to forget anyone, but thank you, everyone, for joining today's session. Preeti is back here. So Preeti, if you would like to give any concluding arguments, we just concluded the session and
Yep.
we're good to go.
Um,
Happy Sunday. Yeah.
Thank you,
yes,
Alka.
happy
Thank
Sunday.
you.
Thank you, everyone.